All right, hey everybody, we are going to start our noodle thing and our new little thing, excuse me, and it's going to be about volume. So I wanted to do a quick demonstration on volume before we get into the notes because there's a lot of stuff that goes into volume. And so the type of volume that you talked about in the 7th grade, I believe you guys talked about, maybe you didn't talk about volume in the 7th grade, but I'm pretty sure we talked about the shapes that were rectangular prisms, so something that's like a 3D box. And then you also talked a little bit about cylinders. So we are going to start with cylinders again. And so I found a cylinder in my house that was clear, and the cylinder I chose was a cup because this was the only clear cylinder that I could find. Obviously mine's not a perfect cylinder. If you look at the bottom of my cup, it kind of slants inside the actual cup. But what I want you to note here is that the bottom of this thing is a circle. I even labeled something on the bottom, that R. Do you remember what R stands for? R is half the distance across the circle. It's from the center to the edge of the circle, and that is called the radius. So we, in the 7th grade and before that, talked about how to find the area of a shape. And the area is like if I were to take a marker and color the whole bottom, that would be the area of the bottom. It's completely flat, there's no like dimension to it, but it just covers. So area covers a shape, and to find the area of a circle, we actually use the formula, and I've got this lovely little notepad here. We're gonna find out how to get the volume of a cylinder, but first we're gonna use the area of a circle because the base of this shape is a circle. So I know that to find the area of a circle, I'm doing pi times the radius squared. That's how I get the area. Now, pi is an irrational number, 3.14, blah, 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 blah. And it is a ratio of the circumference to the diameter across the circle. But anyway, that's something you talked about in the 7th grade. It's not as, we won't go over that again right now. But here's why it's important. Before I can start getting the volume, which is how much fits inside this cup, I need to know how big the bottom of the cup is, because that's where I'm going to start accumulating volume. That's where I'm going to start accumulating like stuff inside this cup. So I labeled this cup. I made 1 centimeter, 2 centimeters, 3, 4, 5. Yes, I colored all over my cup. And I have a cup of water here that I'm not going to spill, and I'm going to start filling my cup to figure out how much volume fits in here. Now this isn't going to be super mathematical because I didn't actually, like this cup again, it's like slanted on the sides, but the idea is if I put in just a tiny little layer on the bottom, I'll have like an area, but it won't have depth up to 1 centimeter. But if I were to take my water and fill it up to the 1 centimeter, I can't believe I just guessed that. That was really awesome. Okay, so now I have the whole area on the bottom, but it's popped up a whole centimeter. So it's like I took this original area, pi times the radius squared, and I multiplied it up 1 centimeter of depth. Now, when you multiply by 1, it doesn't change the number. If you say, hi, I'm 14, or I'm 14 times 1, it's still 14. So when I times by 1, nothing changes. But what happens if I take my cup again, and now, oh boy, I fill it up to 2? Well, now I'm multiplying not by 1 anymore, I'd be multiplying by 2 spaces up, because I'm taking that chunk of water and I'm making it 1 chunk of water along the whole area, and then I'm doubling it to be 2 chunks of water above the whole area. And we can keep doing that. I can do 3 chunks of water, and that would be multiplying by 3 for how high this area goes. 4 chunks of water, 5 chunks of water. I'm definitely gonna spill it. Okay, there we go. Almost to the very top, but I've got 5 chunks of water there. Which means, because this cup was only 5 centimeters high, I would only be multiplying that area of the bottom by 5 chunks going up. So you're not always going to be using a cylinder with 5 chunks of space, okay? Your cylinder is sometimes going to be taller than that, sometimes it'll be shorter than that. So how do we account for any size in the whole world? I can't just say that you're always going to multiply by 5. Sometimes you'll have something that's not 5. that's when we have to use another variable. So what variable could we use to talk about how high up this cup goes, or any cylinder? All right, so we already have R for the radius, but since the other thing that changes is the height, we're just gonna multiply by how high we have to make that chunk go up and up and up. So this is going to be our formula for finding the volume of a cylinder. Now, as you can imagine, a cylinder looks like this. I want you to picture how a cone looks different. A cone would be getting rid of there and there. You'd be getting rid of so much more of this shape. So a cone would actually be smaller than a cylinder. If actually, this is a good point. When you go to get, you're gonna hear Miss Johnson rant about something. You know, when you go get snow cones and stuff, and it comes in a cone, that's so annoying, because like if they gave you a snow cup, you'd get tons of stuff in there. But when they do a cone, they cut out all that space where they could have given you lots of food. So, rip off is what I'm saying here. But we're gonna talk in just a second about how a cone actually cuts out 2/3 of the space. So a cone is only 1/3 of this, which is why they often try to give you a cone. Remember, people are always trying to rip you off in life. That's my lesson for today. Just kidding, that's not the lesson. The lesson is volume. Okay, so a sphere is even weirder than that, because a sphere like rounds out along the edges. I'm not gonna go into total detail on the sphere, but you'll see the formula. It's really weird. Actually, it's not that weird, but we're gonna look at the formulas on the next video. We're gonna do practice problems, and then your homework, whatever, everything's home right now. Your work is going to be finding the volume of cylinders, cones, and spheres. So I want you to think about this stuff that we just talked about, because that's how we got the original formula, and then all these other formulas kind of base out of that original cylinder formula. All right, bye 8th graders.